Bismillahirrahmanirrahim. Students, today we'll discuss about strictly increasing and decreasing function. Let's take an example. We'll solve it by step. For step 1, we'll first take the derivative of the function, which is f dash of x equals 3x square minus 6x minus 24, and 60 is constant, it becomes 0. Let's solve the equation. Now. Let's take common 3. 4x and plus 2x minus 8, so it becomes x into x minus 4 plus 2 into x minus 4, so it becomes x minus 4 into x plus 2. It is the value of f dash of x. Now for step 2. In step 2, we'll put f dash of x equal 0. F dash of x, which is 3 into x minus 4 into x plus 2. In this step, we'll find the critical points, so we'll put f dash of x equal 0. Here we have x equals minus 2. In next step, it is step 3. We'll first arrange the value of x critical points. We'll first arrange the critical points in ascending order, which will be minus 2 and 4. X equals minus 2 and 4. It is in ascending order. Now keep in mind, to make the intervals, we'll write the intervals minus infinity and minus infinity to minus 2 is the and the next interval is containing these 2 points, minus 2, 4, and all of these intervals would be open interval. Next interval will be 4 into infinity. To make the interval, keep in mind that these 2 points will make one interval, and one interval will be from minus infinity to the first value to the first critical point, and the other interval will be from the second critical point to the plus infinity. If there will be 3 critical points, then it will make one more point, say 5. Then we have the intervals like minus 2 to 4, and then 4 to 5, and then 5 to infinity. So these are our interval. Now let's see what is the step 4. In step 4, we'll check either the function, in which interval the function is increasing and in which interval the function is decreasing. Value of x, the function is increasing if for the value of x f dash of x is greater than 0, and it is decreasing if for value of x f dash of x is less than 0. Now let's see f dash of x. The value of f dash of x is 3 into x minus 4 into x plus 2, which we have found in first step. Now check the value of f dash of x in all of these intervals. For this interval, let's take the point for interval 1, minus 3. For this value, what will be the f dash of x? F dash of x becomes, that is minus 3, it becomes minus 7, which is negative value, and it becomes minus 1, which is also negative value. So here negative becomes positive, so f dash of x is greater than 0. We just need to check either f dash of x is greater than 0 or less than 0. So at the point minus infinity to minus 2, the function is increasing, strictly increasing. Now to check at point minus 2 to 4, let's take a value, any value of x, that is say 1 or 0. Let's take 0. We'll check for 0. F dash of x is, if we take x equals 0, it becomes negative, and this value become positive, so negative and positive becomes again negative. So here f dash of x is less than 0, so at this value the function is strictly decreasing. Now let's check on the third point, which is third interval, which is 4 to infinity. Let's take x equals any point, say 5 or 6. Let's take 6. It implies f dash of x At point 6 it becomes positive, 6 minus 4 becomes 2, and 6 plus 2 is also a positive value, so positive becomes positive. So here the function is strictly increasing. Students, as we see in all of these three intervals, we see in first interval the function is strictly increasing, in second interval the function is strictly decreasing, and then again in third interval the function is strictly increasing. In all of the intervals the function is once the function is strictly increasing, and in the interval it will be decreasing, and in the next it will be increasing, and the next it again will be decreasing. So it will be its arrangement in the intervals.